Hi everyone, I want to make a quick video about this type of problem where we use the definition of a derivative to solve a limit problem. So we have three formulas here. We'll just call them number 1, number 2, and number 3. Number 1 and 2 are the derivative at a point being this x value. A is an x value, a specific x value. And then number 3 is f prime of x, right? This is an equation. The answer to that limit problem would be an equation, okay? The answer to the first two would be a number. So when we see a problem that looks a whole lot like one of those limits, in other words, you look at, for example, I'm going to call this first problem here 1. You look at this limit here, and it looks very much like number 1, the red one, because what we're seeing is that we have an h going to 0, just like here, and then we have an h here. We have obviously some sort of a difference quotient here, and this could well be my f of a plus h, and then this could be my f of a, and it looks just like number 1, right? It is number 1 for the function f of x equals rad x. I'm seeing here the radical, right? So my function could be the square root function. The a value is 9, right? And you're seeing that in there. So the a value is 9. And this whole limit, this entire thing, if I were to just box this whole thing, that thing, all of it, it means f prime of 9 for f prime of 9 for the rad x function. So we now do the problem not by rationalizing and finding limits and all of that. We do it by just finding f prime of x for this function that you know is 1 over 2 rad x, and you evaluate it at 9. So 1 over 2 rad 9, which is 1 over 6 is your answer. Okay. So the idea here is to match these limits to one of these three equations, then figure out the function, figure out the a value for number 1 and 2 type of formulas, and get your answer. Okay, so let's see here. Now the next one, number 2 here. This right here, I'm matching to formula number 1. I'll just write the formulas that I'm matching to on the side here. So matching to 1, it looks like my function, well, the only function we're seeing is some sort of an e to the x, right? So we'll guess that the function is e to the x, and we will guess that my a value right here, right, is negative 2. Okay, so something to check with these, and I'll go back to the first one and check this as well, is that if your function is correct and your a value is correct, then this right here should work out to be f of a, right? Because that's that term there, f of a. So if f of x is e to the x and a is negative 2, then yes, f of a is e to the negative 2. So that checks out. So this is f prime. This whole limit, this whole entire thing means the limit, the derivative f prime of the e to the x function, and we're at the specific point negative 2. So then I go off and I think, well, f prime of e to the x is just e to the x, and then I have to do f prime of negative 2. So this answer will be e to the negative 2, or 1 over e squared. So this is the idea. Let's do a couple more here. This one is matching to formula number 2, right? How do I know? Well, look at the limit here. Look at the arrow number. The arrow number looks like x is going to a. It's not h going to 0. So I'm matching to formula number 2. Clearly the a is 2. For that type, you're just going to take this value here, 2. X minus 2, x minus a. So a must be 2. And the only, this one's kind of easier to match because you're going to see your f of x right here, right? So it's just x to the 6th is your f of x. If all of that is true, then f of 2 should be 64, right? Because we should be seeing f of a here. So let's just double check that 2 to the 6th, yeah, that's 64. So that checks out. So this is the derivative f prime of 2 for the function x to the 6th. So now you go off and do it by the power rule. F prime of x is 6x to the 5th, And so now you just do 6 times 2 to the 5th, which is, I think, 192. Okay, so this is the idea. Let me show you a trig one down here, for example. Here we've got, I think we're matching to the first formula, right? And so I'm going to guess that my function is cosine x. That's the only function we see there. Here's my a value of pi. And then the derivative of cosine is negative sine x. This looks like f prime of pi, right? The whole limit means f prime of pi. So now I put pi into negative sine x. I get negative sine of pi, which would be 0. So that's how you do these problems. I'll let you do the other two here and practice by yourself. But let me do a couple from the homework D4. Let me move on to another slide to do that. Okay, so this is problem number 40 from our D4. I had added some limit problems like this to that set. So if you look at number 40, it looks something like this. And these are the same idea, but just the functions are maybe a little more complicated. And so when you look at this, we're clearly matching to that first formula, right? The one I had in red, which would be the limit as h goes to 0 of f of a plus h minus f of a over h, right? So here h goes to 0, h goes to 0, h on the bottom, h on the bottom. Minus is right here, so this is probably f of a. And all of this right here would then have to be f of a plus h, right? Now you can clearly see, you see like this 1 plus h and another 1 plus h, right? So it looks like a good guess would be a is equal to 1. And the function itself, right, has more than one term. It looks like there's an x cubed here, and then there's an 8 over square root of x over here, right? So I would say the function looks like x cubed plus 8 over square root of x. And so then, you know, if you did f of 1 plus h, you would get exactly that, 1 plus h cubed plus 8 over square root of 1 plus h, okay? And let's check if all of that is the right guess, then this number right here, right, that number should be f of 1. So let's make sure that that happens. If I do f of 1, I'm going to get 1 cubed plus 8 over the square root of 1, which is 1 plus 8, or 9. So that checks out. With this guess, f of x equals that function and a equals 1, f of 1 would be 9. And this whole limit, this entire thing, the whole thing, right, this whole thing means f prime of 1 for this particular function, right? So f prime of x first will be 3x squared, and then you have to think of this as 8x to the negative 1/2, and use the power rule to get negative 4x to the negative 3/2. That's your f prime. And f prime of 1 then would be equal to 3 minus 4, which is negative 1. So that's how you get negative 1 for that. Okay, I'll show you one more. Let's try to do number 44. Okay, so number 44, we have limit as x goes to 1. So I'm already noticing that I'm going to be matching to that second definition, right? Because here we see x going to a. And then here you have all this stuff, minus 7 over x minus 1. Okay, so it looks to me that a is 1, right? That's just right here and right here. Okay, a is 1. Remember, in this case, we're matching to this formula. The limit x goes to a, f of x minus f of a over x minus a. So a is clearly 1. F of x, here's your minus sign, right? So it looks like all of this right here is your f of x, right? So your f of x is going to be 4x cubed plus 3 over square root x, which is 3x to the negative 1/2. So if that is all true, then f of 1 should be 7. So let's just check. 4 plus, 3. 1 to the negative a half is just 1. So this is 7. So that checks out. So then the whole thing here, the entire limit answer, right? This is going to be a number, remember? And that number is going to be f prime of 1 for this particular f of x. So now we just need to do f prime of x. That is 12x squared minus 3 halves x to the negative 3 halves. And then you just put 1 in to get f prime of 1, which would be 12 minus 3 halves, which is 21 halves will be our answer.